Today we're going to start section 6.4, which is similar and congruent figures, and I'm just going to go ahead and apologize for the writing today. I'm out of town and I left my stylus at home, so I'm going to have to write with my fingers and it's going to be pretty rough. So just kind of a forewarning there. Okay, so let's go over this box right here first. It tells us about the properties of similar figures. Okay, so it says if we have triangle ABC, and this sign here means is similar to triangle DEF. It tells us that the corresponding angles of similar figures are congruent. What that means, if my triangle ABC, this angle A is going to be congruent to angle D, which is what it just tells me down here. Now, if we're looking at a triangle, how we can mark that is we can say angle A is congruent to angle D, and we're going to do one little curved line. Okay, I can just look at my name, right, and I can say angle B is congruent to angle E because they both come second. So if I wanted to mark that, I could mark angle B with two curved lines, and I would do the same thing with angle E. And then finally, I know that angle C is congruent to angle F. I'm going to mark it with three curved lines. Okay, so kind of just using a picture, that's how you can visually see which angles are congruent to each other. Now, probably the more usable piece of information is this number 2 down here that says the ratios of the lengths of corresponding sides of similar figures are equal. We're going to be able to use that little piece of information all throughout the rest of this section and the next section as well. So we'll get to that part a little bit later. Okay, so first thing we want to do is we want to be able to name the corresponding angles and the corresponding sides. I know I drew you a picture there, but you really don't even need the picture. If you just look at this piece right here where it says triangle ABC is similar to triangle DEF, you could tell all of the corresponding angles and all the corresponding sides just from the names. But what we're going to do is we're going to go through and we're going to start with angle A. And I want to say, okay, angle A. What angle corresponds to angle A in triangle DEF? And like I said, you can actually tell which angle is going to correspond to angle A just by looking at the given piece of information. Since A comes first, notice I have A, B, C, the first letter in triangle DEF is going to be its corresponding angle. So angle A and angle D are corresponding angles, and what that means, they are congruent. So if you want to, you could go ahead and you can mark your congruent angles. Okay, I also know that angle B, since it comes second, is going to be congruent to the second letter in my second triangle. So angle B and angle E are also corresponding. So if we mark those on my triangle, I'm going to mark angle B and angle E with two curved lines. And then finally, the last letters in both of my triangles are angle C and angle F. So if I wanted to mark those, I would have to mark those with three curved lines. Okay, now the cool thing is you can do the same thing but with the corresponding sides. So we talk about the sides of the triangle. So if I want to start with, let's say, side AB. So if I want to find the corresponding side to side AB, all I have to look at is where A and B fall in my name. And they are the first two letters in my name. So that means DE are the corresponding sides in my second triangle. Okay, if let's say next I want to look at side AC. And if I want to find the corresponding side to AC, well, I notice that in my name, A comes first, C comes last. So if I look at my second triangle, D comes first and F comes last. So AC and DF are corresponding sides. And that only leaves two other sides. So if I look for side BC, in my name, BC are the last two letters and EF are the last two letters in triangle DEF. So BC and EF are my corresponding sides. Okay, so that's one thing that you're going to have to do today. So if you flip over your paper, I'm not going to do it because it's going to pause my video and mess everything up. But if you flip over your paper to the next side, you're going to have a set of directions that says The figures are similar. Find the ratio of the lengths of the corresponding sides of figure A to figure B. Okay, so the first little piece of information I'm going to tell you is that we are given triangle STU is similar to triangle VWX. We're going to say triangle STU is my figure A, triangle VWX is figure B. That will be important, and you'll kind of see why. We're going to have to test out our drawing skills here. We need two right triangles, and I need you guys to be very careful. Make sure you're labeling the same as I am, or you will end up with a different answer. So we're going to let triangle S be that top point, T be the bottom left, and U be that bottom right. And then for my second triangle, once again, still have a right triangle, but this time the top point is going to be W, bottom left will be X, and the bottom right will be V. And the last little piece of information we need is some side lengths. So we're going to say ST is 5, SU is 4, and TU is 3. WV is 15, WX is 9, and XV is 12. Okay, if you think back to that box that we talked about at the very beginning, it told me that the ratio of the corresponding sides, the ratio of the lengths of the corresponding sides of similar figures are equal. So I have two similar figures, so the ratio of their sides should all be equal. So what that means is I can set up a ratio from figure A to figure B using some of the sides. So we're going to start with ST. And what we're going to do is we're going to look for the corresponding side from ST to VWX. So remember the trick that we learned on the last example. ST are the first two letters in my triangle. So VW will be my corresponding side in my other triangle. So ST corresponds to VW. Now if I write its side lengths, its equal side lengths on the other side, well, ST measures 5, VW measures 15. And if I simplify that, I can divide out of 5 from both of those figures. So the ratio of the lengths of the corresponding sides from figure A to figure B is 1 to 3. Now here's the thing, if these really are similar figures, all of the sides should turn out that way. So let's try one of the other corresponding sides. This time let's try TU. And remember, since we're going from figure A to figure B, I need to put figure A's side lengths in the numerator, figure B in the denominator. So if I look for the corresponding side from TU, I see that it should be WX. So I should have the side length of TU over the side length of WX. Well, TU is 3, WX is 9, and if I simplify that, I can divide out of 3 from both of those numbers, and I end up with 1/3. Okay, I want you guys to pause the video. I want you to check that last side and set up your ratio and your side lengths and simplify it. Make sure you still get the same thing. Okay, you should have set up SU is to VX, and SU measures 4, VX measured 12, and whenever you simplify it, you notice that all of your side lengths equal 1/3. Okay, let's look at one more of those examples. This time we're going to look at a quadrilateral. So this time we're going to be given F, G, H, J is similar to K, L, M, N. And we're going to let F, G, H, J be figure A, K, L, M, N be figure B. Okay, so we're going to have a smaller, it's going to be a rectangle. We're going to start the top left-hand corner is K, and we're going to work clockwise, L, M, N, and then my other side is, once again, starting the right-hand corner, F, G, H, J. Okay, so we need some side lengths, so we're going to say KN is 3, NM is 5, FJ is 4, JH is 6 2/3. Now you have to be really, really careful because remember, The directions told me that I wanted to give the ratio of the lengths of the corresponding sides of figure A to figure B. So I need to put the sides of figure A in the numerator and the sides of figure B in the denominator. Notice that figure A is actually on the right-hand side. Okay, so that's the one thing we need to be careful of. So let's find some corresponding sides. Now I know what the side FJ is, so I'm going to find the corresponding side for FJ. Now if I look in my given statement, F came first, J came last, so its corresponding side should be KN. So I'm going to have FJ over KN. Okay, well FJ measured 4, KN measured 3. So my ratio should be 4/3. Let's go ahead and check that other side just to be sure. Okay. So we're going to look for the corresponding side of JH. Now notice in your given statement, JH are the last two letters, so MN should be its corresponding side. Okay, well JH is what measures 6 2/3. MN measures 5. Okay, now this is where you have to be kind of careful. Think back to whenever you're dividing fractions, because that's really what we're doing. We're really taking 6 2/3 divided by 5. If I want to divide fractions, I've got to change my mixed numbers into improper fractions. So if I change 6 2/3 into an improper fraction, I'll get 20/3 divided by 5. But whenever we divide fractions, we have to multiply by the reciprocal. And I can divide out of 5. So you do end up with 4/3. So once again, if you checked all of the sides, it would always be equal.